in the beginning with too much theoretical talk of global level and that, but that was very important in my view to set up the context of why we need to act on energy management other than the factory level issues. But when we're talking about factory level now, so what do we need to look at factory level? So this is a factory sketch, and if you see, there are multiple aspects of energy that we need to look at. If you see on the left hand side, we have energy supply issues, we have fuel supply issues, then we have inside the factory we have, for example, inefficient combustion, which is resulting in emissions, waste heat, carbon dioxide, methane, nitrous oxide, particulate matter, sulfur oxides, nitrogen oxide, smoke, and all this gets deposited into the soil then, which obviously then causes trouble for the community. And then we have process or material waste, and you can see this word NPO everywhere, and I will explain this word after a few slides. So just remember this word NPO, because we will be using this NPO word a lot during our session. So we have process or material wastes in the factories. Then we have products going out of the factories where we have emissions from transportation. On the right hand side, you can also see in the bottom we have waste going towards landfill. We have solid control and soil quality control as well. Then we have wastewater coming from the factory, where if the waste heat is not recovered, it would be hot wastewater going out. And when it reaches the effluent treatment plant, and if it is, for example, a biological effluent treatment plant, this needs 40 degrees or less temperature. And if the temperature is higher in the ETPs, then they have to operate cooling towers as well. So then we have more energy consumption there. Treatment also requires generally more energy, and then there are emissions because of that. Then the sludge goes out to the soil, and during the treatment, even if we have biological treatment, we have emissions like methane is emitted during the biological treatment as well. This is a perspective. So looking at what we can do in the input side, as I said, we need to look at energy security. So sustainable supply of energy, then clean energy. I wanted to write energy cost, but I mistakenly wrote clean cost here. Then inside the factory, we need to look at the leadership. So what kind of leadership is there in terms of energy management, how they're progressing. Then energy efficient procurement and design. So is the factory procuring efficient equipment? Is the factory designed according to the efficiency requirements? How are the process controls? So process control improvement is very important. We saw that in a plastic molding factory, they were molding plastic into car parts. So we requested them to change their process parameters in a way that does not affect product quality and does not increase process time. But what we did was that we reduced temperatures, we increased some speeds of injection and some other parameters. With that, we were able to reduce their energy cost of that process. The quality remained the same, the process time remained the same, but the energy cost could be improved. So process control is very important. Awareness and training is also very important aspect. So if the people are aware about energy losses or not, then analysis and reduction of NPOs. NPO is a non-product output, and any inputs which do not end up in the final product are called non-product outputs. So we have either product outputs or non-product outputs. So for example, if we provide heat to the process, but the fabric that goes out of the factory is not hot, it does not have heat energy, that means all that energy is a non-product output. It is not up in the product. So how do we analyze, how do we reduce the non-product outputs? That is what is coming in the process part. Then output part, fulfilling customer requirements, incineration with energy recovery, waste upcycling. So if we have sludge, for example, going out, how can we put it into a circular economy and convert it into a usable product, for example? Talking about wastewater, so how can we reduce the wastewater generation or recover heat from wastewater? How can this wastewater be upcycled or recycled? So wastewater recovery, then waste heat recovery from the emissions, improving the quality of emissions. So putting up the filters there to improve the emission controls and also ensuring legal compliance. So these are the aspects in input, process and output side that we need to take care of when we are starting at the factory level. So what happens is sometimes the auditors or the energy efficiency service providers only look at the process part and do not look at the other parts. These other parts are very, very important in setting up strategically the energy management system. So the framework as suggested by ISO 50001 is that the energy management system should be set up as a plan, do, check, act cycle, so PDCA cycle. And in the middle is leadership. So leadership is the core of it, which drives planning, which provides support to the operations, which provides performance evaluation guidelines, and also monitors the improvement process. This is how it should be set up. Looking at different aspects of energy management system, first of all, we should start with understanding the organizational context. So what is the scope? What kind of leadership is there? What kind of issues do they face internally and externally? How is the leadership taking lead? Do they have policies? Do they have teams in place? Have they identified their risks and opportunities in terms of energy? Have they set up their targets or not? Then talking about energy and greenhouse gas inventory. So what kind of energy mix do they have? Is it a sustainable mix? Do they have renewable energy in their mix or not? Are they accounting for their greenhouse gas emissions or not? Which are the biggest greenhouse gas emitters? Then conducting an energy review, developing a process flow diagram, conducting an energy profiling. Where is the energy coming from and how is it being used? Identifying which are the biggest energy users, identifying which are these wastages or non-product outputs where we can reduce our cost, and then doing a prioritization. So which are the bigger ones that we need to take care of? Then doing the action planning, setting up energy performance indicators. These are the things that we will talk about in details in today and next day sessions as well. Setting up baselines, developing energy data collection plans. Then we move forward from plan to do part, that is supporting the actions, providing resources by top management in terms of time, in terms of money, in terms of training and competence development and awareness, communicating to the employees how it is and why it is important for the company or factory to work on energy management system, setting up the right procedures, then setting up operational controls. As I spoke earlier, are our operational controls effective or not? So for example, if we need to heat up the process to 74 degrees, is our process capable to maintain it to 74 degrees, or does it fluctuate too often? So this is one aspect, that when we are conducting a process side energy efficiency assessment, we need to see the process capability as well. Then considering energy performance in design and procurement, that we call design for performance or design for energy. That when we are developing a new factory, a new facility, are we considering that energy efficiency, energy performance is maintained or improved at that time or not? Then performance evaluation. So monitoring and measurement of energy evaluating if the targets that we set are being achieved or not, ensuring that our legal compliance, customer compliance is on track or not, ensuring that there is an internal audit done so that the system is checked and the management is conducting a proper review. This also leads to from the leadership as well. And then continual improvement, so sustainability, checking effectiveness, checking if every year we are improving, or the improvement was only done once in a while and then we again started to reduce our performance. So this is an overall framework that we will be talking about, but obviously we will be speaking less about management in this workshop overall 5 days, and we will be talking more about the technical aspects of it, more talking about the textile process as well. But these are the things that we need to keep in mind. We change our point of view for the time. So what is NPO? Whenever we have to look at non-product outputs or wastages, we need to change our point of view. When we go to factories, we often ask ourselves that there are so many wastages there in the factory. Don't they see these wastages themselves? Sometimes yes they do, but they want to shut their eyes from those wastages because they have too many other things to do. But sometimes they do not know that there are wastages. So recently I went to a factory and they said that we do not have any compressed air leakages. We are very efficient. We close down all the valves as soon as the machine is shut down. So we don't have any leakages. So I asked them that during the break, they should shut down their machine, but should not shut down the air supply. So they kept the supply open, and then they saw so many leakages inside the machine, which they never knew that they were there. So when the machine is operating, these leakages are happening. But since there's a lot of noise of machine, they never know that this noise is coming from compressed air leakages or are these noise coming from the machine. As soon as they stop working on the machine, they turn off all the valves, they cut off the supply of air and steam, so they never see that there is any leakage. But when we calculated, this leakage was enormous. So many moving parts and static parts of compressed air were leaking, and now they have started fixing, and now they say, okay, now we need to have a plan of action for identifying and eliminating leakages. So we have to change our point of view. The starting point is to see which inputs are there, which process do they go through, and what is our desired final product. So our desired final product in a fabric mill is a finished fabric. In a garment mill is a finished garment. So we have to see which of the inputs go through each of the processes and end up in a certain output. Inputs, we have raw material, energy, and water, which are used in the process. We also have chemicals and some other auxiliaries, which go through process, and then we have a desired final product. But not all the inputs end up in the final product. So we have electricity in the input, but in the garment that we are wearing, when we touch it, there is no electricity. We don't get an electric shock. That means the electricity was used in the generation process only, and then it was converted into heat or some other kind of energy, and it got emitted somehow. When it got emitted, it is still an output, but it is not a product output. It is a non-product output. So if we have, for example, wastage, let's say that 90% of our material ended up in the final product, but 10% of our material ended up into wastages like cutting wastages or rejections or reworks, for example. 10% of waste material is our non-product output. And accordingly, 10% energy that was applied on the whole process also went into waste. 10% of water also went into non-product output or waste. Along with that, in general, the whole water is also going into waste, which we can recover or recycle. But at least this 10% associated to the process of generating the waste also went into waste. So when we need to calculate the total non-product output cost or total waste cost, we need to calculate the input cost that waste went into waste. So for example, if we have 10% wastage, that means 10% energy and water and raw material went into waste. And then we also have disposal cost. We put them all together, and then we also add the process cost, that is land use cost, labor cost, time cost, and all that. We put them all together, and then we come up with total waste cost or non-product output cost. One mistake that factories do is that they say, okay, we had 10% wastage, and since we purchased fabric for, let's say, $100 per meter, we had 100 meters of wastage. They multiply $100 with 100 meters, and then we say this is our wastage cost. No, we also have to account for energy and water cost and process cost and disposal cost. That is when we see that the wastage carries very, very big cost, not only material cost, but also energy and water. So if we are able to separate the production cost and non-product output cost and profit, we can make separate accounting headers. Then we can visualize the NPO costs. And when we can visualize the NPO cost, that is when we can try to reduce. Then we will know, okay, where are the wastages going and where we need to reduce the cost. The companies who are not tracking their wastages, who are not calculating the right wastage cost, when they try to reduce their overall production cost, they start laying off their management and their workers. They think, okay, how we can reduce salary? But salary is not the biggest contributors towards our reduced profits. It's the wastages which are the biggest contributors. So if we are able to reduce our NPO or wastage cost, we can maximize our profit without laying off the laborers or without laying off our top or middle management.